if f of negative x equals to f of x, then f is an odd function. Alright, so, and I didn't write that correctly. Better fix your notes. Sorry about that. Negative f of x. Okay. So, otherwise what I had up there was the even test. Alright, so let's go with that again. If f of negative x is the negative of f of x, then f is an odd function. Alright, does that look like an F? You know, I really don't feel like redoing this video. F. Alright. What does it say in plain English? Well, if I change the input to the function, it changes the output. And otherwise the number stays the same. So think about f of x equals to some number which is a y value. But if I change the input, it changes that y value to the opposite sign. And that's why we're seeing this jump into these different quadrants. When I change an x coordinate, it jumps across. And when the y coordinate changes signs, it jumps up or down across the axis. So this is the test for an odd function. We'll test it on this just to show you what it looks like. So f of negative x, referring to this function, I replace x's with a negative x, and I get negative x quantity cubed minus 4 times negative x, and that becomes, this will be negative x cubed, this will become plus 4x. Now it is not equal to the original function, but if I factor out a negative sign, I get x cubed minus 4x. Factoring out the negative, the parentheses is identical to the original function. So this is equal to minus f of x. There we go. So that satisfied the test for an odd function. All right. Well, I'm going to put up another odd function to go through that, give you another example of this. Here's our odd function, and I decided to use g instead of f just for change of pace. Okay, g of x is just a name for a function, really, and so what you name a function doesn't matter. It's obviously when you're determining the even or odd functions, it's what the outputs end up being. All right. Well, anyway, this is 4x cubed plus 2x minus 6 over x, and to test it, I need to plug in negative x, and we get 4 times negative x cubed plus 2 times negative x minus 6 over negative x. So here we get negative 4x cubed minus 2x, and then here the negatives cancel, plus 6 over x. So if you compare these, how do they compare? Well, all the signs are opposites, which means that if I factor out a negative, I would get positive 4x cubed plus 2x minus 6 over x. And this exactly matches the beginning function, so that's negative of the original function, g of x. So we need to write a conclusion. This function is odd. All right, so I'm not sure exactly what it would look like. I could guess at it, but it's odd, which means that the right side and the left side are going to be symmetric around the point, around the origin point. So if I rotated the right half around the origin 180 degrees, I get the left half. So that will be the aspect of the graph that will come out of this exercise here. All right, so I'll give you 1 or 2 more examples of this time. I'm going to give you some functions which are neither even nor odd, and people get tricked up on these. So don't take this too lightly. Be careful about what you're looking at with these. All right, well, I'll erase the board and put those up. Here's this function, h of x. I changed the letter again. H of x is x to the third power minus 2x plus 5. And on the surface, it may appear to be an odd function. So, be careful about generalizing these. You can really fool yourself if you're not careful. This is not an odd function, and it's not an even function either. And even though the exponents are odd numbers, think of this as x to the first power. But what is the exponent of 5? 5 what? Well, actually, it's the exponent of 5x to the 0 power. So the exponent of x in this term is 0, which is an even number. All right, well, let's see what happens. If I change this input, h of negative x gives me minus x to the third power minus 2 times negative x plus 5. And that results in negative x cubed plus 2x plus 5. And it's not the original function, obviously, because these signs are different. So it can't be an even function. And if I factor the negative sign out, I would get positive x cubed minus 2x minus 5. So factoring out a negative also does not give me the exact same function because the 5 is what's different. So this is neither even nor odd. There we go. So that, like I said, most functions out there are neither odd nor even. What the symmetry properties of symmetric around the y-axis, symmetric around the origin point are very specialized, are very unique. So not too many functions have those, but there are some common functions which enjoy that property. For example, the cosine function ends up being an even function, and the sine function in trigonometry is an odd function. And those, so you see even odd properties throughout all the trigonometric functions. And there are hyperbolic functions which can have these properties. I don't know them off the top of my head. But anyway, some functions out there do have even and odd properties which can be exploited. It's nice to know that if you're thinking about analyzing something, whether it's even or odd. So anyway, this is a traditional college algebra topic, and again, it gives you a little more experience at some kind of analysis. And since we're studying functions, it seems to be a pretty natural one. So, well, that's what I had to say about even and odd functions.